back. Chapter 7, Section 7.6. Normal approximation to binomial distribution and p-hat distribution. Focus points. State the assumptions needed to use the normal approximation to the binomial distribution. Compute mu and sigma for the normal approximation. Use a continuity correction to convert a range of R values to a corresponding range of normal X values. Convert the X values to a range of standardized Z scores and find desired probabilities. And last one, describe the sampling distribution for proportions p-hat. Let's see what these are. Now, the probability that a new vaccine will protect adults from cholera is known to be 0.85. The vaccine is administered to 300 adults who must enter an area where the disease is prevalent. Okay, so the probability of success is 0.85. Okay, what is the probability that more than 280 of these adults will be protected from cholera? So you want more than 280 successes. This question falls into the category of a binomial experiment. Number of trials n is 300. Probability of success p is 0.85 and the number of successes are greater than 280. Now, it is possible to use the formula for the binomial distribution to compute the probability that R is greater than 280. However, this approach would involve a number of tedious and long calculations. I hope you remember what we are talking about. So, if you remember the table for probability of R successes, so this is probability of R successes, all right? So R could be 281, you calculate. R could be 282, you calculate. You're going to calculate like that for all greater than 280 until 300. So 281, 282, 283, 284, so on until 300. And then you are going to add all those numbers. So this is a large number of tedious and long calculations. There is an easier way to do this problem for under the conditions stated below. The normal distribution can be used. Okay, so instead of calculating for each R, you can use the following normal approximation to the binomial distribution. So, you have a binomial distribution. N is number of trials. R is number of successes. P is a probability of success on a single trial. Q is a probability of failure on a single trial. So Q is 1 minus P. Now, if N times P is greater than 5 and N times Q is greater than 5, then R itself has a binomial distribution that can be approximated by a normal distribution with mu NP and sigma square root NP. As n increases, the approximation becomes better. So, big condition, n times p should be greater than 5, n times q should be greater than 5. All right. So, graph the binomial distributions. Okay. In our case, so we have p. So, here is an example. P equals 0.25. So, q is 0.75. Number of trials is 3, then number of trials is 10, then number of trials is 25, and then 50. So for various n's, right, you're looking at R here, 0 to 3, when you have 3 trials. Okay. Mu is n times p, sigma is square root n times pq, all right. Now, When n is 10, this is your probability distribution. You can see it's getting approximated by a curve. When n is 25, the same p, the same q. All right. Now the curve is better approximating it. All right. And lastly, when n is 50, you see a much better approximation of the picture with the curve. All right. When n is 3, the outline of the histogram does not even begin to take the shape. So when n is 3 is here, outline of the histogram is this. It doesn't even begin to take the shape of a normal curve. When n is 10 or 25 or 50, it does begin to take a normal shape. From a theoretical point of view, the histograms and figures would have bars for all values of r from r equals 0 to 1. Okay. However, in the construction of these histograms, the bars of height less than 0.01 have been omitted. Okay. Probabilities less than 0.001 have been rounded to 0. So what they are talking about, look at here, the bars, these bars are getting tinier and tinier. Each bar represents a probability. So if probability is less than 0.001, it has been rounded to 0 and the bar has not been drawn. Okay. So procedure, how to make the continuity correction. Convert the discrete random variable r to the continuous normal random variable x by doing the following. If r is a left endpoint of an interval, subtract 0.5 to obtain the corresponding x. If r is a right point of an interval, add 0.5 to find the x. For instance, if you have p, if the question were 6 less equals r less equals x, replace that r by an x after reducing by 0.5 on the left, adding 0.5 on the right. So you are expanding this a little bit. X is the corresponding normal random variable. So this is an important thing to note. You would replace r by x by decreasing it a little bit and increasing the right endpoint a little bit. Okay. So 6 to 10, you are going a little bit to the left and a little bit to the right. So you're basically looking at the curve from the right end point of the rectangle here to the left end point of the 6th rectangle here. Okay. Which brings us to sampling distributions for proportions. We'll come to this in our next video. Until then,